Control of atmospheric moisture and mould growth. There is broadly a condensation season. This is generally between September and April. If there is dampness outside that period, it is probably not condensation. There are basically 5 major factors that need to be investigated. Ventilation. Is it adequate for the occupation and volume of the property? Similarly, is the heating adequate? How is it being used? Moisture production. Is it reasonable given the variation in lifestyles? Are there possible excesses, for example drying clothes? Airflow. Movement around and behind furniture. Is it adequate? Insulation. Are there specific cold spots? The above are usually grouped together, generally, as lifestyle, that is, the effects of occupation. So what is lifestyle? Well, for our purpose, it's water generated by occupation. A domestic property should be able to cope with this, or rather a normal lifestyle, that is, with normally accepted activities, no overcrowding, no unrealistic moisture generation from bottled gas heaters, drying clothes, etc. And if we look at it, there are 2 extremes of normal lifestyles. Family 1 has cereal for breakfast and salads, tea, etc., with minimal cooking and mostly out all day. Family 2 all have cooked breakfast, fully cooked dinners in the evening, young children, and some occupation all day. The property should be able to cope with both extremes by one means or another, and appropriate systems should be in place to allow this. The average domestic property is not designed to manage additional extraneous sources of water, such as from paraffin heaters or continual use of unventilated dryers. So back to control of atmospheric moisture and condensation. Improve ventilation. What are we doing? We are sweeping out moisture-laden air and replacing it with drier air from the outside. In reality, however, we don't totally replace it. We are effectively diluting it with dry air. And this is the theory of ventilation. Perfect ventilation would throw out all the internal air and replacing it with external air. So we'll have the same amount of air outside as inside. No ventilation, internal vapour is significantly higher than external because it's not being swept out. In reality, we could call it ventilation. Internal vapour is higher than the external, but at an acceptable level because it is being diluted and partly thrown out by means of the external air. Typical ventilation rates as a whole system there from well-sealed dwelling in sheltered position to leaky dwelling in exposed position, and they're from BS 5250. Ventilation again, fans, manual or humidistat, and constant running. These remove water from source. We also have positive pressure systems. These in essence bring in air from the outside via the eaves and push it out, say, onto the landing. The air outside, of course, being drier. We then create a slight positive pressure in the property which pushes out moisture-laden air. The one on the right at the bottom shows us a positive pressure system designed for use in a flat. So the positive pressure unit then sets up a positive pressure internally, bringing in the drier air from the outside via the eaves, and this pushes out the damp air in the building as a whole. Constant running fans, such as ones using in a bathroom and kitchen, these are designed to, for want of another word, suck out the damp air or push out the damp air, and it's replaced with drier air from other parts, including the outside, because a negative pressure is set up and the dry air moves in. Open windows, not too easily if you live in a ground floor flat, say in a city, but it works. No obstruction to air vents. Trickle vents in double glazing. On their own probably do very little, but with other systems such as fans and PPIs, excellent. Given that major areas of water generation are bathrooms and kitchens, it really is important to remove that water at source. Reducing subfloor condensation, well, first of all, reduce internal moisture levels, because such moisture with a higher vapour pressure will pass beneath the floor where it's colder. We should maintain good airflow, and if we have a damp oversight, then we can put polythene over it to slow down evaporation. I mentioned it earlier, but the principle of ventilation is to replace the internal moisture-laden air with drier air from the outside. In other words, we're diluting the internal air with dry air. It's therefore imperative that the air dilution concept is fully understood. There are, however, in relation to landlords and rented properties, there may be implications in relation to the rate of ventilation, mostly with fans and open flues, and a gas safety inspection by GasSafe may be. Improve heating, make it constant, not intermittent. Has other advantages of raising the temperature of surfaces of walls, etc., and lowering the humidity in general, therefore lowering the risk of condensation and mould growth. In reality, ventilation and heat are basically controllable factors and should be the first items assessed, and if possible installed or improved. Provided no obvious excess moisture production, lifestyle overall, namely talking about putting lids on pots and pans and other items, should not be the first point of control. One should therefore keep the relative humidity in a domestic property below an average of around 60% at 20 degrees. This should be the same for any property, irrespective of size and what we could regard as normal occupation. If we cannot achieve this average, then one needs to investigate why. Ventilation, heat, lifestyle, for example, drying clothes over radiators. We saw this earlier, the effects of heating on wall surfaces, especially intermittent heating, but it does show that wall surfaces do heat up very quickly and therefore lower the relative humidity of any air in the boundary layer against that wall. We saw this, how condensation can occur at various times, well beyond the times that we expect it, not during the day, perhaps during the early morning. Reduce sources of moisture. Don't use bottled gas heaters, etc. Don't dry clothes over radiators, unventilated dryers. This activity can overload even the most efficient ventilation and heat systems. Improve surface temperatures, we can insulate. Improve the thermal properties of walls, keep them dry. If one gets water penetration into a wall, not necessarily through it, then that lowers the thermal property. If we can stop that, say by an external silicon coating, then the thermal property of the wall will improve. Dehumidifiers are good. However, for moulds, we need to eliminate the moisture causing the problem, and this is followed by. But it should be fully appreciated that the risk of indoor air quality problems leading to these organisms is greater in a distinctly damp internal environment than a dry one. It therefore becomes imperative that nobody should persistently occupy a damp internal environment, and it is essential therefore to get the building back into a suitably dry, clean state. So let's go back again. For the average domestic environment, we have mould. But then do you need to require a mould expert when it's found? No. If you can recognise a mouldy orange, you can recognise mould anywhere. You are now a mould expert. So what would you do if you found mould? Would you go and take samples, get them analysed? Indeed, if these were allegedly innocuous, would you leave it? The answer is no. You don't change your corrective procedures based on the species of mould. The cause is the same, water. And this cause is irrespective of the mould type. Control the water, that is the fix. It's impossible to eliminate all mould and mould spores in the indoor environment, and similarly, visible mould, although not a precise measure of exposure, is probably the clearest risk indicator for potential exposure. Air sampling for fungi should not be part of a routine assessment. Decisions can be made about remediation based on a visual inspection. Furthermore, it is only a snapshot, as we'll see in a minute. The primary objective is based on guidelines published between 1993 and 2004, that is, remove visible mould growth and return material surfaces to a satisfactory condition. Finding hidden mould is difficult and expensive. There are, however, odd occasions where one may have to look for it. Searching, therefore, for hidden mould is fear-based marketing, virtually never needed, and expensive. And remember, its visible mould is the reasonable endpoint. Going back then to air sampling, here it shows the inherent variability in air sampling for moulds. Get massive variations in very short time periods, even using the same traps positioned in opposite directions. So there is these massive changes can take place over very short periods of time. Therefore, we are only reading a snapshot of what is going on. There will be a large difference, for example, between sampling while somebody's walking in the room and sampling possibly with all the windows open half an hour later. Sampling for moulds is almost irrelevant. These figures, by the way, are by kind permission of Forensic Applications in Bailey, Colorado. So what do we do? Well, the aim is to keep a reasonably low relative humidity, that is below about 80%. This avoids the development of mould growth. And remediation of the conditions that lead to adverse exposure should be given priority, as identified in the World Health Organization 2009. And very importantly, building owners are responsible for providing a healthy workplace or living environment that is free of excess moisture and mould by ensuring proper building construction and maintenance. The occupants are responsible for managing the use of water, heating, ventilation and appliances in a manner that does not lead to dampness and mould growth. Therefore, it splits the responsibility between the landlord effectively and the occupants. Visual and olfactory inspection is the most important step. Cleaning up is complete when there is no visible mould, there are no mouldy odours, and, very important, you have fixed the moisture and water problem so that it will not recur. And again, a repeated theme is most practical approach is simply to eliminate all visible mould growths and smells from the environment. So considering cleanup, if moulds are found in a building, prudent practice recommends that visible mould be removed. It is very unlikely that hidden mould poses a problem. Use the simplest and most expedient method that properly and safely removes mould. There we are. Wash down, anti-mould washes, brushing with HEPA filter, and indeed steam cleaning is reported particularly effective. However, very heavily contaminated material may not be readily cleaned and may have to be removed. Please note that if there is a significant amount of mould present, if it is positively known that occupants have distinct medical conditions which could potentially compromise their health, then speedy clean-up using appropriate control protocols should be put in place. There are issues other than toxicity and allergic responses attributed to mould that are experienced by atopic individuals. And these are frequently the same responses that might arise in a sensitive individual exposed to pollen, dust, house mite feces or animal hair. So it is therefore important that fixing the damp reduces and retards other organisms or items which are implicated in potential problems in persistently damp buildings. But it is extremely important that if it becomes known that a sensitive individual might suffer harm from any such environmental conditions, then professional medical advice should be immediately sought by those individuals. Indeed, if anyone complains of ill health, then they should always seek medical advice from those qualified. And finally, no one without a medical degree should offer opinions on health of patients, and no practicing physician should assume a cause and effect from the limited data available on one patient or even a group. Anti-mould washes, bleach or a suitable biocide, continuing with control of condensation and mould. Anti-mould paints are very useful where the problem is severe, for example in difficult areas such as and there's an anti-mould paint after 10 years of exposure. On the left is the normal paint, on the right, under the same conditions, is the anti-mould paint. Very effective. For interstitial condensation, most of the above, but especially improve ventilation, plus remove any external vapor-resistant layers. This will allow water vapor to pass freely out through the wall. And install an internal vapor control layer on the warm side. This slows the water vapor into the wall, thus reducing the risk of interstitial condensation.